let's get going. So my name, nervous. My name is Noel Weichtbrodt. I'm the principal engineer at Spokestack, and I'm talking about how voice is just another interface. So let's give a quick history of interfaces in the 1890s. Arguably earlier, Charles Babbage was out there, but productized around 1890 were punch cards, cards with hole punches in them. You fed them to a computer. So there was no interface other than that. If you wanted to tell something to a computer, punch card into the slot. Computer reads it, spits an output, usually also a punch card. That persisted to about 2012. Goodbye, punch cards. Supposedly Florida still had them in their voting system around then. I don't know of any other use. If you know of somebody who's still using punch cards, let me know and I can update this because that'd be fun. 1910, keyboards started coming in, so tappity tap. Digital displays, so not necessarily what you think of as monitors, but just like lights, things lit up and the lighting indicated the output. So keyboard input, lighting output. The idea of keyboards and digital displays is still continuing to the present day. 1968-ish, Engelbart gave the mother of all demos, showed off the mouse for the first time. Everybody was super stoked. Also showed off like a GUI and a whole bunch of other stuff. So we started the paradigm of clicking and seeing a visual representation as an interface around 1968. And obviously that's still with us. 1973 was a touch screen. Touch screens are like, obviously, what I just did, that gesture, was a touchscreen specific gesture. I couldn't do that on anything previous to the touchscreen, which leads us into like gestures and haptics. Think like Microsoft Kinect, or if you're old school, the Nintendo Power Glove. Anyone? Power Glove? Power Glove family? Yes? Good. Awesome. And haptics, so like feedback. So I don't think the Power Glove had haptics. Did it vibrate? I don't think so. But gesture with vibration feedback or whatever. On your phone, the vibrations are a form of haptic feedback. And then starting in 2010, we started having voice as a common consumer interface. Obviously, like Dragon Dictate was out there in the 80s and whatnot, but that was kind of a niche type thing. We're talking like interfacing with a computing device for everyone, starting in 2010. So if you think about like, we got into big arguments, in like even the 80s about like what a good graphic interface was supposed to be, right? And the technology for a GUI has been around for what, 30 years before that? So 30 years later, after the introduction, still arguing about it. We're very early on the voice as an interface like cycle. So there's not a lot of like agreement about what interfaces should look like as far as voice goes. So that's a history of interfaces. There we go. All right, so kind of voice is the final frontier of interfaces. Let's do a little bit of vocabulary. Big fan of introducing a domain and giving you the words that we use in that domain. First word is wake word. It's where you transition from passive listening to active listening. So let's use my favorite captain. You may have your favorite captain as an example. So when Jean-Luc Picard says computer, he is using a wake word. The computer then transitions, the ship's computer then transitions from passive listening to actively listening for what Picard is going to say next. That's a wake word. Automated speech recognition. So when Picard says tea, Earl Grey, hot. So that's an utterance. So prepended with the wake word, computer, and then utterance, tea, Earl Grey, hot. The computer takes that speech, turns that speech into text. So ASR is turning speech into text. If you haven't noticed yet, computers still don't do well processing just plain speech. So we're using text as an intermediate representation in order to process meaning later, which brings us to natural language understanding. When Captain Picard says, tea, Earl Grey, hot, how does the computer respond? Like some important like beeps and boops, I guess, from the replicator, and then like magic happens, and then the tea comes out. So NLU, a natural language understanding, turns text into computer understandable commands. So the same way that you would define what a key press on a keyboard means, the same way that you would define what a gesture on a touchscreen means. A NLU turns that text into something that the computer can understand. And then finally, there's the output, the text-to-speech. This is where we take, based on the computer's processing of the commands, it may decide, I want to say something back. The way to say something back is TTS, using a synthetic voice. So that's the vocabulary that will be, or I start you off on the vocabulary. So let's break it down one more time. Oh, nope, sorry, that's not ASR. That is wake word. So Picard says something like tea, or computer. Picard says tea, Earl Grey, hot. Then the computer does things, right? It understands that what Picard intends it to do is to prepare what? Organic matter. What kind of organic matter? I got tea, we got Earl Grey, and we got hot, right? So that intent and slot represents a command. If it's a bad computer, it says, I can't do that, Dave. Just to mix up my sci-fi series. So you're now probably wondering, okay, this is great. I want to put on my Captain Picard voice and talk to my computer. Why haven't I been able to do that my entire life? So this graph starts to answer the question. This graph represents ASR accuracy. ASR accuracy is measured as the word error rate. As a human, we have a word error rate of 4%. In 1988, computers had a word error rate of 90%. As we move on through time, we got down to about 20% in 1999. Magic happens between 1999 and 2001 or 2011. The magic is machine learning. Machine learning suddenly becomes a viable approach to solving natural language processing problems. And the improvements have increased exponentially since then. So you can see we dropped from 20% in 1999 to 20 years later, 2.6%, whereas it took us 11 years to get down from 90 to 20%. And obviously, at this point, each order of improvement represents a whole lot of work. You usually just don't get these things for free. So 2.6% is actually amazing, it's notably better than humans. So that's kind of table stakes though, right? So you can't do anything until you can actually get speech into text computationally wise, right? If you don't have a representation of it, you can't deal with it at all as a computer. Next step, once that got good enough, is NLU accuracy. So sorry, I accidentally erased my slide there. So 90% accuracy on across like a broad test corpus is the current state of the art. So 90% is reasonably good. If you think about it, like how often you misunderstand somebody else, I don't think any of us, at least me, would claim to be, super accurate as far as understanding the meaning behind things. And then TTS accuracy. TTS is a subjective accuracy measurement. We use something called mean opinion score, which is like on a 1 to 5 scale. 1 is like totally intelligible. 5 is like, this is the best voice and I want to hear it for the rest of my life. Angels are literally singing into my ear. So humans score around 4.5% on MOS. The very best state of the art for synthetic voice is about 4.21%. So not terrible, not great, but probably good enough to start using. So together we have reasonable ASR accuracy, we have reasonable NOU accuracy, and we have reasonable TTS representation. So it seems like the future is here. Now, what do we do with it? So 81% of us own smartphones. 52% of us, of the people who own smartphones use voice assistants. 43% of the people who use voice assistants use them for search. But I think 100% of us want to be able to say Earl, sorry, I have to remember to write, gray, hot. That would be something that would be wonderful to be able to talk to our computer and get tea back. We're working on that. So this is a talk about Spokestack. Spokestack is a service company. The service we provide is tools to help add voice to your mobile apps. We think about the Spokestack offering as having 3 legs. The 3 legs are ASR, TTS, and, TTS is not quite there, NLU, TTS. We have ASR done, that's available right now. We have TTS done, that's available right now. We're working on NLU. That literally working on it today, should be soon. So we've also tried to give you some good semantics for how to work with these 3 legs. So to start your ASR, you say start. Using a speech pipeline to start classifying or to start recognizing like intents, you take your text and you say classify to get an NLU-based intent out of there. Once you get the intent out of there, your app decides what to do. That's where your app magic happens. Then you're ready to maybe say something back to the user. That's where you say Spokestack TTS.speak. And we play back sound, the synthesized response for you. There'll be a lot more detail about that slide later. So that's a big overview of Spokestack. We have docs. We have a tag on Stack Overflow. We have a social handle. Thank you.